Before we pick up some example problems to have a discussion on, let us recall the concepts we studied about in our last two sessions. If sum of two angles is 90 degrees, then the angles are called complementary angles. To find the complement of a given angle, subtract it from 90 degrees. If sum of two angles is 180 degrees, then the angles are called supplementary angles. To find the supplement of a given angle, subtract it from 180 degrees. Two angles are said to be adjacent angles if they have a common vertex, a common arm, and the uncommon arms are on either side of the common arm. Two adjacent angles are said to form a linear pair of angles if their sum is 180 degrees. In a linear pair of angles, the uncommon arms are in opposite directions. When two straight lines intersect at a point, two angles which do not form a linear pair are called vertically opposite angles. Vertically opposite angles have a common vertex, but they don't have a common arm. Before proceeding further, if you have not subscribed to my channel, please do it now. Also, like my videos and share them. Let us take an example. Example 1. Identify which of the following pairs of angles are complementary and which are supplementary. Here is the first pair, 65 degrees and 115 degrees. Let us add them up. They add up to give 180 degrees. Therefore, what is your conclusion? Of course, they are supplementary angles. Here is another pair, 63 and 27 degrees. Their sum is 90 degrees, so they are complementary angles. Here is a third pair, 112 and 68 degrees. They add up to get 180 degrees. These are supplementary angles. 138 and 42 degrees. Let us find their sum. It is 180 degrees. Therefore, these angles are supplementary. 43 and 47 degrees. Their sum is 90 degrees. So, these are complementary angles. 80 and 10. Their sum is 90. So, they are complementary angles. Let us take another example. Find the angle which is equal to its complement. Angle and its complement must be equal. You have to find such an angle. Let the angle to be found be x. Complement of x equals x as given in the problem. X plus x equals 90 degrees because they are complementary angles. 2x equals 90 degrees. It is a simple equation. Let us solve this equation for x. We get 45 degrees. Therefore, the measure of the required angle is 45 degrees. Let us take another example. Example 3. Find the angle which is equal to its supplement. Let the angle required to be found be x. Supplement of x equals x as given in the problem. X plus x equals 180 degrees. Sum of two supplementary angles is 180 degrees. 2x equals 180 degrees. Let us solve this equation for x. We get x equals 90 degrees. So, the measure of the required angle is 90 degrees. 90 plus 90 is equal to 180, isn't it? Let us take one more example. Example 4. In the adjoining figure, answer the following questions. First question. Is angle 1 adjacent to angle 2? Angle 1, look at the figure. I am marking angle 1. Then angle 2. Are they adjacent angles? Let us check. For angle 1 and angle 2, the common vertex is obviously O and the common arm is OC. This is the common arm. Uncommon arms are OA and OE. These are the uncommon arms. They lie on either side of OC, don't they? So, OA and OE lie on either side of OC. Angle 1 and angle 2 are adjacent angles. Second question, second sub question is angle AOC adjacent to angle AOE? Let us mark the angles. That is angle AOC. This is angle AOE. Are they adjacent angles? For angle AOC and angle AOE, the common vertex is, of course, O and common arm is OA. Uncommon arms are OC and OE. These are the uncommon arms. The uncommon arms OC and OA lie on the same side of OA. So, angle AOC and angle AOE are not adjacent angles. Did you get it? Now, do angle COE and EOD form a linear pair? This is angle COE and this is angle EOD. Look at the figure. Do they form a linear pair? Let us check. For angle COE and angle EOD, the common vertex is O and common arm is OE. Uncommon arms are OC and OD. They are in the opposite directions. The uncommon arms OC and OD lie on either side of OE. So, angle COE and angle EOD are adjacent angles. Moreover, OC and OD are opposite rays. We have already seen that. Therefore, angle COE and angle EOD form a linear pair. This is another question. Are angle BOD and angle DOA supplementary? This is angle BOD. Look at the figure. These are the two angles we have to deal with. For angle BOD and angle DOA, the common vertex is O and common arm is OD. Uncommon arms are OB and OA. These are the uncommon arms and they are in opposite directions. The uncommon arms OB and OA lie on either side of OD. So, angle BOD and angle DOA are adjacent angles. Moreover, OB and OA are opposite rays. Therefore, angle COE and angle EOD form a linear pair and hence are supplementary. This is the fifth question. Is angle 1 vertically opposite to angle 4? Let us check. These are the two angles we are dealing with, angle 1 and angle 4. Angle 1 and angle 4 are formed when straight lines AB and CD intersect at O. These are the straight lines. They don't form a linear pair since they don't have a common arm. So, angle 1 is vertically opposite to angle 4. Let us move on to the next example. Example 5. Here is a figure. In the given figure, are angle 1 and angle 2 adjacent angles? Let us check. This is angle 1, this is angle 2. We have to check whether these two angles are adjacent angles or not. For angle 1, the vertex is P. For angle 2, the vertex is Q. It's quite obvious. But two angles to be adjacent angles, they must have a common vertex. But these two angles have different vertices. They have a common arm, but they have different vertices. Therefore, they don't form a pair of adjacent angles. These are not adjacent angles. Let us go to the next example. Example 6. We know that angles in a linear pair are supplementary. Using this concept, prove that vertically opposite angles are equal. Let us get a figure first. Here, straight lines CD and AB intersect at O. We need to prove that angle COB or angle BOC is equal to angle DOA. Angle AOC is equal to angle BOD. How to prove that? Let us see. First, let us identify a linear pair here. Angle COA and angle BOC form a linear pair, that is angle COA. This is angle BOC. They form a linear pair, don't they? Now, their sum must be equal to 180 degrees. Transforming this equation, we get angle BOC equals 180 degrees minus angle COA. I have brought angle COA to the right side. Let us take this as equation 1, result 1. Now, similarly, angle COA and angle AOD form a linear pair as well. Angle COA plus angle AOD equals 180 degrees. That is angle COA and this is angle AOD. These two form a linear pair and their sum must be equal to 180 degrees. Again, transforming this equation, we get angle AOD equals 180 degrees minus angle COA. This is result 2. In result 1, in equation 1, angle BOC equals 180 minus angle COA. In equation 2, angle AOD equals 180 minus angle COA. Each of angle BOC and angle AOD is equal to 180 minus angle COA. Therefore, angle BOC must be equal to angle AOD. This is the first result we needed to prove. Similarly, these are the two angles equal. Angle POC equals angle AOD. Similarly, we can prove that angle COA equals angle DOB. Angle COA must be equal to angle DOB. Please give it a try. Hope you enjoyed this session. I have discussed only a few selected problems in this session. If you want more problems to be discussed, please let me know in the comments section. In our next session, let us learn about parallel lines and their properties. Till then, bye.